Good afternoon, good evening to everyone. Thank you for joining this short session with me for debugging techniques for modern software developments. So I'll try to keep it short. So I'll get started with my introduction. So I'm a principal engineer at ZoomInfo. ZoomInfo is a B2B company based out of the US. I do have more than 17 years of experience. I've worked in like multiple Fortune 500 companies. And previously, I worked with Wayfair, Walmart, IBM, and many others. I do have expertise in software architecture, design, delivering the complex digital transformation. And I recently started with AI augmented software development as well, where I'm doing a lot of AI related development. So having said that, so today's agenda, 5 major categories, which I wanted to cover. And before I get started, so I'm under the weather today. So let me know whenever you see like the voice is not clear or it's something is, if you have any questions, let me know. Feel free to interrupt. So 5 major categories I'm going to cover today. So starting with the introduction, what is debugging, why we want debugging, debugging techniques, best practices, and what's going to be there in the future. So let's get started actually. So if we talk about the software development history, right, 1940s, 1960s, where the software development started, where we are having like room size computers, mainly using for the punching the card. Then we go for a structure programming, 70s, 80s, where the programming language is like CCAM. But it's my kind of transition from hardware focused development to the software center approaches. 1990s, 2000, then the rise of object-oriented programming came, where the Java, C++, everything came, and the modern era when the 2010 plus present, which covered the current landscape, including the cloud computing, mobile applications, and AI. So that's about the history of the software development. What is the importance of the debugging? So there are a couple of points like the identifying, the fixing the errors. The purpose of debugging is to find and fixing the bug in the software. It ensures that the application perform as intended and any issue can be hindered its functionality are resolved. So that's the first importance. The next one is the software quality. The regular debugging help to maintain the higher software quality for the software. And if there is any flaws leading to, we can improve, we can make it stable and reliable product by using the debugging. The third one is the enhancing the user experience. The bugs and error in the software can lead for poor user experience. And I'll later explain like how we can lose the company, lose the revenue, lose the confidence in the user by having the bugs. And the cost efficiency, addressing the bugs early in the development process can save a lot of costs. Again, I'm going to discuss in next one of my slide how much cost it can be for a company finding the issue after the deployment or during the later stage of the development life cycles. So let's go to the next one. So what is the definition of debugging? What is debugging? So debugging is a systematic process where we are identifying, we are diagnosing, we are fixing the bug and defect in the software. And it always like not about the fixing the bug. It's all about the understanding why it occurred. And we need to ensure that it does not happen again in the future. So that's what the main objective and that's what the debugging is. Now, what is the trend of the debugging? What kind of debugging methods we are having? So in the beginning, we used to have an early manual method where we manual process looking at the code review, checking the machine output early in the era of the software development. Then comes the print debugging where we are adding the print statement and trying to see like where the code execution is going step by step. Then come the interactive debugging, where we are introducing the IDE, setting up the breakpoints, stepping into the code, inspecting the variables at runtime. So that's the third phase coming into the debugging. And the last one, which is still in very, very early phase, is like automated debugging. So it's a modern practice where the automated tool can detect, they can log, sometimes they can even suggest fix for bug as well. including the AI-based solutions. So it's still early phase, but there are tools like the one of the tool which Facebook is using. So let's go with the next one. Why we need a debugging? So if we see, right, half of the programming is coding. That's the one of the code which I copied, right? So half of the programming is coding, other 90% is debugging. So we need to understand, we need to know how we debug. So there are need in terms of need, like the first one is the cost implication. So CISQ is a report by CISQ says cost for poor software quality in US 2020 was approximately 2.8 trillion. It includes the cost for unsuccessful projects, legacy system problems, software failures, operational insufficiencies. According to IBM, the cost to fix a bug during the implementation phase was six times more expensive than we identified during the design. So it's major cost implication. So that's the one reason we need a debugging. The next one is the economic impact, right? So software bug can cause a significant economic impact during the direct loss to like downtime, and then there is a repair. So one of the instance, like in Amazon 2018 Prime Day glitch, it estimated cost like $99 million to the sales to Amazon. So again, I mean, it will be a downtime cost, and we are losing the customer trust as well. So if there is a downtime in online businesses, it can cost $10,000 per minute, as per the study to a e-commerce website. So these are the impacts, and that's the reason we really need a debugging. We need to find the bug early in the stage, make sure it does not happen again. Let's move to the next one, where we are saying, what's the traditional debugging technique? There are two traditional debugging technique. One is the print debugging, where we are developer or engineer insert a print statement in their code to output of variable values, program states, or flow indicator, how the program is flowing. And it is a way to understand what program is doing in particular point of time. But there are pros and there are cons with the print debugging. It's a simple and universally applicable for all the application, but it can be time consuming. It is a less effective for the complex bug or the like distributed environment, multi-threaded environment. The next one is the manual code inspection. So as a process of systematic reading line by line code and find the error. So it's kind of sometime involved checking the logic, checking the syntax, whether there's a coding standard or not. So printing out is one technique, and the manual code inspection is heavily dependent on the developer experience and knowledge. It can be very effective for catching the suitable logic errors, but however, it's a labor intensive and it can be a subjective. Let's move to the next slide, where we are talking about the modern debugging techniques. So I categorize these in four different parts. So number one is integrated debuggers or IDE. Uh, so integrated debugger IDEs, for example, IntelliJ, Eclipse, or Visual Studio, they offer a powerful debugging features. These debugging features are integral to the development process. These include like setting up like breakpoints, how to pause the execution of the program at specific line of the code, and it allows developer to inspect the current state of the program. This also allow stepping through the code line by line, right? And examining the variable value, how the call stack has been made in the program execution. It's particularly very, very effective in the complex application. The next categories come automated error detection. So automated error detection tools are significantly reduce the manual effort required to identify the bug. So one of the tool like SonarQube, it performs the static code analysis to detect the potential vulnerabilities, bugs, and code smells. And nowadays there is like the plugins are also coming, so it can be easily inject with your any of the IDE, and you can see these things early in the development phase. Log file analysis is another debugging technique. So in a world, right, where the application are distributed, deployed in cloud environment like AWS, GCP, anywhere, log file analysis become very, very crucial. And there are tools like ELK that provide the powerful capabilities to aggregate, search, analyze the log across the different services. So that's the third one. And there are a couple of more which I categorize in the others, like the version control. So we can manage and track the changes by using the version of control, so that there can be like we can use any tool. The Git and GitHub is a very famous tool. You can identify when and where the bug was introduced. So we can go back to our Git history. We can see, okay, what was the last change deployed, and we can easily roll back and provide the stable version. We can roll back. We can see, okay, this changes went. We can go to the previous one and deploy again. The next one is the error tracking and monitoring tool. Is very important. So monitoring the application in real time to detect, log, and alert the errors. So there are tools like New Relic. There is famous tool Datadog. So we can send all our log information to these tools, and they can help us to set up entire monitoring pipeline. They can quickly identify the errors, and they can alert us, especially in the production environment, how the services are doing, what's the uptime, downtime. There are a lot of features available by using this monitoring and error tracking tools. The last one, which I wanted to talk about, the remote debugging. So for example, let's talk about a scenario where you identify a bug in production environment. You really can't debug, and it's only happening in the production environment. How you gonna identify that? So there are tools in the market which can help you to do a remote debugging in production environment. And one of the tools which I came across is Rookout. So it's easy to configure. You can go and put a breakpoint in your production environment and see like how the step-by-step execution is going on. So that's about modern debugging techniques. Let's talk about some best practices, what you should do while you are debugging a code or found a bug. Okay. So the first very important things, understand the problem which you are trying to fix. Don't move forward without understanding it. So get the problem statement, or maybe understand the error message or problem. Try to identify the problem symptom. If the error messages are available, read it carefully to get the clues about what might be wrong. Or if it is coming from some other person, from QA or from business, understand the problem thoroughly before you start it. Then the next step will be like reproduce the issue. Try to replicate the bug on your local environment, on your staging environment. Understand the condition under which the bug is occurs. It can help you to diagnose the problem. The one more thing in understanding problem is break down the problem. If issue is complex, break it down into smaller part. It can involve so for example, if the issue is coming, you can have like multiple layers. Try to narrow it down by identifying where exactly the problem is, and then work on that. Use debugger tools and technique effectively. So leverage the integrated debugging tool, as I said, like IDE, best like stepping into the breakpoint, see what the value is coming, what value is coming, look at for call stack, utilize the logging and tracing. That's another thing. Always see for what log has been printed to see like step-by-step execution where it's failing. And the last one is static analysis code, where you can see like how the log has been printed. Okay, where is there any anomaly in the log? Is there any error is coming? The third one is adopt the methodological approach. So always like do incremental changes in testing. So make small incremental changes and then test frequently to avoid the bug in your system. This is make easier to identify which changes fix or which changes cause the issue in your production environment. Document the debugging process. So sometimes you have a complex system. Always document the debugging process, how you are debugging, not for the simpler system, but for the complex multi-threaded distributed environment system. It can be valuable for the future reference, and it can help in understanding the evolution of the problem solving process for other engineers. Peer review and peer debugging is another point which I wanted to bring in. So always like it help a fresh set of eyes can spot something you have missed. Collaborating with the colleagues bring new perspective and solution to the table. So always remember, right? Saying that, having said that, always remember debugging is not just about the fixing the immediate issue. It's always about the opportunity to understand system better, improving the coding practices to prevent the similar issue happen in the future. So this about the best practices. Let's go for next debugging technique. So this is one of the screenshot I took it from internet. So if you see like there is vertical how effective it is, how often I try it. So there are a couple of points. Let's talk about the take a walk. So one of the best tools for debugging code is walking away for 10 to 15 minutes from system. So if you recognize any time that you are frustrated, you're stuck with a tricky problem or running around the circle, take a break. A 5 to 15-minute break will help you to re-energize, reset your psychological state. You may return with a new solution. It happens with me many times. So always take a help. I always take a walk whenever you're stuck with a tricky, complex problem. Yeah. So the next one is rubber ducking. So when you explain problem to someone else, the important things is not just who you are speaking with, but that in doing so you're also explaining it to yourself. Some developers, when they ask for the advice to me or anyone, say we can say like explain your problem to the duck first. A good way to resolve many problems. The one point in the same section talk to the rubber duck is leveraging AI. So nowadays we do have like Chat GPT. We can leverage that. We can give the prompt and everything, and it's kind of a continuous conversation at both the end. You may maybe find it effective with the traditional rubber duck approach, as these two can respond and take part in the back and forth conversation. And the last one, which I wanted to cover on this slide, is very important. It's not mentioned here, but always ask the right question while doing the debugging. So these questions can involve like, what is the goal of the code? What exactly we are trying to do in this piece of code? What does the code actually do? Right? How are the issue you what are the issues you found with the code? What exactly the issue, right? Have you encountered these kind of issues in the past, right? What was the solution when you identify these issues in the past? What was the fix? And what do you think can cause this bug or this issue especially? So asking the right question is very important while you are doing the debugging or the code. Yeah, let's move to the next one. So the next one is like, what is the future of debugging in software development gonna look like? So the number one point will be the predictive debugging. So AI and machine learning algorithms are being developed. They can predict the bug in the future. And there are tools right now as well. It's very early phase. So they can predict the bug based on the historical data and code pattern. And they can automate the code fixing, where the system is not only identifying the bug, they can suggest, even implement the fixes as well. So one of the tool which doing currently is Facebook's Fix, which use the AI to suggest the bug fixes, how it repent bug fixes, automatically creating the PR. Sometimes it's merging the code as well. The next one is VR AR in debugging. So I believe personally that there is a potential of VR AR. It can create the immersive debugging environment where developer can interact with the code and system in the 3D space. It can be very particularly useful in understanding the debugging complex large scale application, providing like holistic view how the different components part system will interact with each other. It can be very useful debugging the IoT and embedded system related debugging. The last one which I want to talk on this slide is enhanced automation and integration. So predicting the evolution of more integrated development ecosystem where debugger tool are combined, we can anticipate like smart automation as well, like how we are automating debugging in it will potentially reaching to a point where the system can self-diagnose, self-repair to a larger extent. So it is anticipated in the future that there will be automation, there will be integration, and everything could be, at a large extent, everything could be repair itself. Um, yeah, so that's about like how the future gonna look like. Having said that, this is my last slide, so I can take if there is any questions.
It's Gabriella here from MLH. I guess I'm curious at what point, like in your career, since like you said you had about 17 years of engineering experience, did you find that like debugging got at least a little bit easier from like I guess your beginning days?
Exactly. Yep. Yep. So I found it like very, very easier nowadays. Um, Earlier when I started my career in 2005, it was very, very difficult. Like not having like like many tools. So the IDE was not very rich in debugging, very difficult, like printing the statement as I was saying in earlier slide. Um, Creating a log file, writing everything into log. There was like difficult to implement the log file itself, like the big log files. Getting the log files from the cloud was difficult. Getting it was time consuming. Getting analyzing those was difficult. Nowadays the ID is very, very like good. We can do step by step. That's number one. Number two, log file analysis is very easy. There are many tools like ELK. Number third, the monitoring tool comes in very, very handy, which is Datadog especially. We can set up everything, service integration, how the tracing, end-to-end tracing working, like from request come to the system, what all hops it's making. We can trace it with the trace ID and see like what all component is used, what all services making call, what's the response is coming. So very, very, very helpful. The Yeah, so these are the tools. And as we are moving along with the AI and machine learning, the tools are coming in the market, which is competitor to SonarQube, as well as the tool which is doing the automated testing and fixing the bugs. Like the one of the tool I talked about is Cepfix, which is the Facebook tool.
Mhm.
So they can in the future, it won't be a surprise in the future, like maybe down the line after 2 years or 3 years, the tool will be coming into the market, identifying the bug, creating the PR, and for smaller bugs, maybe they are merging itself. So it's going to be future soon. The Rookout is another good tool which I talked about. It's helpful when you have a bug in production environment which is not reproducible on the staging, especially. So we can use that, put some debugger point in the lookout and see like how it is, what a value are we are getting in variables, where exactly is failing in the production environment code. So we can interact there with our Kubernetes K8 cluster, Kubernetes ports, and we can debug, okay, if this is the faulty code, why this specific pod is having the issue, or why this application is having the issue. So that's another important tool. So to answer your question, it's drastically like very easy nowadays.
Mhm.
Same time, the complexity of application also increased tremendously. So earlier it was very simple application, like the front end and back end.
Mhm.
Nowadays, we are having a distributed application, microservice design patterns, where we are having multiple services running into the production environment. The debugging challenges has been increased also at the same time, but it is comparatively more easy as compared to 2005, 2010, even 2015.
That's very interesting. Sounds like kind of like a combination of like you like becoming more experienced and then also like the tools becoming better over time as well.
Yeah, yeah.
It looks like we have some questions in the chat. Someone is curious if you can show a demo of JavaScript debugging. They always tend to find that difficult. Then a +1 to that as well.
Yeah, we can take it in the next session sometime. It's yeah, I mean, or it's a question from Ketan Rudraksh, right?
Yes.
I mean, so I need to set up some environment, some code. to showcase the JavaScript debugging. But the high level, the debugging skill or the debugging best practices will remain same. Taking a walk is very it was very helpful for me in last 10 years. Understanding the problem statement is the another one, is very helpful before you jump to start debugging. I wrote couple of article on like how we should how we should start reading a new repo on Medium. But I mean, Ketan and Rudraksh, feel free to reach out to me on the Discord, or I do have a ADP, or I'm doing a lot of mentoring over there. So feel free to book a session. We can talk about it in more detail. But I need to set up some environment. I need to take a specific use case, what exactly problem you are facing, and then we can talk more about it.
Yeah, so that makes a lot of sense. And then we have our last question, which is, can you share some tips on how to debug in large code bases?
Yeah, sure, absolutely. So one of the point which I was saying earlier, it's always important to narrow down the problem, right? So the large application, large code base is also having a multiple component. So narrow down the problem. Let's say if we are having 3, 4, 5 components, we need to narrow down the problem. Like, okay, the request is coming to the first component. How it's going to, is it going to the second component or not? If it is going to the second component, fine, let's go do the similar thing with the third component. If it's not going to the second component, we know, okay, the problem is between the first and second component. So narrowing down the problem is the first step I would suggest. The second one is like dependent, see like how the code execution is going in your large code base. So if you are having a log statement, use dot log statement, like how the execution is going step by step. And then try to see like where exactly is failing. The third one is the error message. So if it is like failing somewhere, you might be seeing some error message. So try to trace it back from where exactly is throwing the error. Yeah, and if you have like integration with Datadog or any monitoring tool, go and try to identify like what's the service APM look like. If it is an endpoint, is it throwing some 500, 400 errors, or if it is like any error is coming, like any CPU, memory, some overflow, what kind of error you are seeing in monitoring tool. If all these things does not work, I would suggest start doing some logging, some more logging implementation in your code base, and try to deploy it. Try to deploy it again in your staging environment, in your local environment, and then see like how it's performing. If you have missing like logging statement, yeah, so that's what I would suggest. The last thing which I can say, like if you are spending like any debugging, any code which is P2 or below should not spend more than 2 hours. If you're spending more than 2 or 3 hours, I would suggest, highly recommend to take a walk first thing, or go and talk to your colleagues. It's always helpful to talk, a fresh set of eyes looking at the problem, and try to take the help from them. So if you are spending like more than 2 or 3 hours on a problem, which is like less than P1, P2, P3, P4, if you are spending more than 2 hours, it means you need a break, or you are not looking the problem in right perspective. So you need to change your perspective, take a help from your colleague, your senior, or take a walk, come up with a new fresh set of eyes or fresh approach altogether.